Okay guys, I just want to make a very quick video on how to find the function of g of x. Okay, so this is g, alright, and we denote it as g of x. G of x actually means y, that's what g of x means, but g of x will be distinct from f of x, alright. The meaning of g of x and f of x is y. That's what these actually mean. But g of x is this straight line, okay, which is supposed to be distinct from f of x, which is this line. Okay, so the gradient of this line is positive, whereas the gradient of this line is negative. Okay, so what we are going to do, we want to find the equation of g of x. Okay, now the standard form of the equation of any straight line is y is equal to mx plus c. So what we are going to do, we are going to first find the equation of f of x. So step 1, find the equation of f of x. Okay, remember I said f of x means y. Okay, so let's try and find that equation. So when we want to find the equation of any line, there are two things that we need. We need the gradient and we need the y-intercept. So to find the gradient of that line, we need the 2 points that the line passes through. So we have the y-intercept, which we know is 0 and 6. And then we have the x-intercept, which is 3 and 0. Okay. Now knowing what the x-intercept and what the y-intercept is and the x-intercept is, we can now use these points x1, y1, x2, y2 to basically find the gradient of the straight line. y2, that's 0, minus y1, that's positive 6, over x2, that's 3, x1, that's 0. 0 minus 6 is negative 6, and 3 minus 0 is 3. So I get a negative 2. So that means the gradient of this particular function is negative 2. So I substitute in the place of m, negative 2. Then I follow it up with the x plus what? Plus c. Remember, c stands for the value of the y-intercept, the y-coordinate of the y-intercept. Now, remember, to find the y-intercept, we usually let x be equal to 0. That's why this is 0 is very much appropriate, that it in that position x is 0. So the corresponding y value is basically the c value. That's why I have my arrow pointed there. This here, 6, can then be substituted in the place of c, because it is the y-coordinate of the y-intercept, which is the c value, which is the y-intercept. I hope that makes sense, right? Or if you are someone else, you could go about finding the value of c by substituting what? Any of these 2 points. If I choose to substitute 0 and 6, what happens is that my x is 0, my y is 6, so that means in the place of y, I'm going to substitute 6. In the place of x, I'm going to substitute 0. Then what I'm going to do is I'm going to solve for c. So that means 6 is equal to negative 2 times 0 is 0 plus c. That means c is equal to 6. Therefore, if c is equal to 6, then I can go back to the equation of the straight line. Remember, I had y is equal to negative 2x. That means then in the place of c, I write plus 6, which is this 6 that I got here. Make sense? So that means the equation of f of x is actually, remember, y means f, is negative 2x plus 6. Now that I have the equation of f, alright, remember that the relationship of this straight line and this straight line is that they intersect and they make an angle of 90 degrees. So step 2 is finding g of x, which is basically the equation of this line. Okay, yeah. Another thing to note is that the gradient of this line, since it's a decreasing straight line, should have a gradient that is negative. So it makes sense that we have a negative 2 here because it's a decreasing straight line. Makes sense? Now we want g of x, the equation of this line. Okay. So what I know is that the gradient of f times the gradient of g should give me negative 1. Why? Because, guys, lines that are perpendicular, the product of the gradients of the two lines, m meaning gradient of f of x times m meaning the gradient of g of x, should give me a negative 1. This is a rule that applies whenever two lines are what? Are perpendicular, or in other words, they intersect at 90 degrees. If they intersect at 90 degrees, we say they are perpendicular. Therefore, the gradient of the two lines, the product, meaning the multiplication of the gradients of the two lines, should give us negative 1. What is the gradient of f? It is negative 2. So the gradient of f is negative 2. Why am I substituting it here? It's because this is my way of finding the gradient of g. Gradient of f, which is negative 2, times the gradient of g is equal to negative 1. Now I can actually solve for the gradient of g. How? I am going to divide both sides by negative 2. Why? Because in that way I can then find the gradient of g of x, which gives me what? Remember, negative divided by negative is a positive. 2 divided by 2 gives me 1. So that leaves me with the gradient of g of x, which is equal to what? What's a negative divided by negative? It's positive. Positive what? A half. So my gradient of g of x is positive a what? A half. So now I can write the equation y is equal to mx plus c. This is obviously for the function of g. Okay. So remember, the equation in standard form is y is equal to mx plus c. M, which just found, m is equal to a half. So I'm going to say half for the gradient, what? X plus what? Plus c. Now let's go to the straight line and see if we do have the value of the y-intercept. If we go to the straight line for g, remember we've just figured out that the gradient is positive a half. Does a positive half gradient make sense? Yes, it does. Why? Because this straight line is an increasing line. So if it's an increasing line, we know that the gradient is positive. And it makes sense that we have a gradient of a positive half. So y is equal to half the gradient of g of x, x followed by x plus c. C means the y-intercept. Do we have the y-intercept of g of x? Oh yes, we do. This here, negative 3, is the y-intercept of g of x, which means the coordinates of that y-intercept is 0 and negative 3. Remember, we said for our y-intercept, we always let x be 0. So the y value, this y value, represents the c value that we ought to substitute here. So let me go and substitute it. Y is equal to half x plus negative 3. Then y is equal to a positive times a negative, guys. Why do I put brackets there? It's because I can see that positive is a different sign, the negative 3 is another sign. So positive times a negative gives me a what? A negative 3. So that means g of x is simply a half x minus 3. Or you could write the equation as g of x. This can also be acceptable, x over 2 minus 3. Because remember that this x is not an x that's in the denominator, it's an x that's in the numerator. But if I write it in line with the division sign, that's fine.